Hello and welcome. I'm Bill Wake. We're working on a program to assess the similarity of musical tunes, and we're up to the point where we'd like to capture the time signatures, the meter of the tune. The approach we're going to take is very similar to what we've been doing with the unit note length and the key, that there's going to have to be an event that says change the meter, and we'll have to deal with that. Okay, so handle meter in the tune header, the tune body inline, and then there's an interaction between M and L, the meter and the unit note length, and we'll address that. Okay, so here's the definition. It can be the file header, the tune header. We don't do the file header yet, so we'll ignore that. Tune header, tune body, or inline, and it does things like set 3/4 time or 4/4 time. Let's go find the actual rules for it. Okay, you've got things like 6/8 or 4/4. You can also use C for common time, which is 4/4, and C bar, which is cut time, which is 2/2. And you can say none. And also you can say 2 + 3 + 2/8. Okay, I think that's called an additive meter. It basically says you kind of have sub pulses of 2 beats, then 3, then 2. And if there's no M, the default is free meter. Okay. All right. So we've done a little bit. Let's see what we've got in measure. Basically, we put the rhythm in the measure now, but this should really be meter, which is a little bit different than rhythm. We say that each note has a rhythm or a time for it. The meter, we had the cut time and the 4/4 and all that, the variety of things. They may vary some. So what I'd like to do is introduce the notion of meter, and most of the time it will just be a rhythm, but sometimes it will be more complicated. Okay, so run tests, make sure everything's okay first. Oh, and what's this? I thought I did that. Okay, well, the message went away for a while. I guess that was good. Okay, good. Tests are all right. And what I want to do is basically wrap this into a meter class. Let's just define that class. I'm kind of doing an extract class, I guess you'd say. We'll define a new class. Okay, we'll call it meter. And actually, I really want this to be an enum. We have one of these sum type situations. It can be common time or 4/4 or additive time or free. There's a lot of choices. We don't necessarily have to support most of them at this time, but we will need to support them eventually. Okay, so we have rhythm. Interesting. Measure gets set. Okay. What we want to do is, I'd like to wrap this class. So, I don't know. The easy way may just be let the compiler tell us. Well, let's go the other way. Let's wrap it in here first. Meter of type meter. Meter equals meter dot, well, let's just say, what would be the right word for that thing? Standard, I guess. Okay, so I'm going to say that I'm going to store these things in my class. There's going to be some people out there asking for the rhythm, and we'll have to make that work for them. Okay, so first thing is we're going to add a standard with a rhythm in it. Okay, let's address this with meter, and we'll make a meter I think for now, well, okay, so we'll just put the meter in there. Oh, this is meter. Now, what's interesting to me is nobody's complaining, right? So that tells you how little we were using this measure, the rhythm in the measure. Okay. Measure, so we need meter to be equatable. Something's not right. Oh, there it went. Okay. Measure has no knowledge of rhythm. Okay. Let's give meter a method to do that. I guess I'm going to call it rhythm. Return rhythm. Okay. So this is measure. Dot meter. Now we may not care. Let's see what happens to time signature. Oh, it goes into identify pulses. Okay. And then now I'm already not liking this, but I just want to get it green and then we'll fix that. Okay, so I want to put this function on measure as well. Okay. Returns rhythm. Return meter dot rhythm. Okay, so it's a bit of a pass-through function, but I think it helps a little bit. Measure quantizer. That's that law of Demeter violation. You know, it's doing this dot that dot the other to kind of work its way through to the bottom of something, and we'll just let the pass-through deal with it. Okay, and this should be working. Okay, so we added meter class, use it with measure and quantizer. Yeah. All right. Um, Now, where's this meter coming from? Let's go back to ABC parser and let's find M colon. Huh, not in there. Okay, so we know it's not even dealt with at all, which is probably reasonable. Let's see, where's our event? Oh, I had another thought too. Let's see, event two parts. Right, the time signature comes in here. It's just default meter. We don't ever set it anywhere, so that's why it's just showing up like that. Okay, the other concern I had was we made event two parts. We split it out of Tune Builder yesterday. This was that replace method with method object refactoring. So we had a longish method that we wanted to extract parts out of, and it got painful because it had all these local variables. So we moved it over to a new class, made the variables be fields on the class, and then we could extract and work with it. But I think we should check the tests too. The measures is where I'm starting to care about it. So yeah, this one is really looking at the measures. Yeah, any of these doing measures and apply key signature, those are examples that really more relate to event to parts. So let's pull that out to a test for it. Event to parts test should be a parser test. It's a new file. It's a Swift test. Okay, and whoops, Tune Builder tests. So this one is just doing metadata. Oh, sorry. Part specification is metadata, but this measure, key signature, those are all event tests, event to part tests. Okay, they should all pass, and then we'll go through them and decide if we can simplify things. Okay, well let's lock that in. Move tests from Tune Builder tests to event to parts test. Is it event to parts? I'll fix it in a minute. Okay. Event to parts. Yeah, the test name is wrong. Okay, so I think we're running through the events. Tune.measure 0A. Okay. Let's see what event to parts test produces. I think it was parts, right? Yeah. Okay, so let's see what we can do there. I think parts. We need the events. Let's try let parts equal tune event to parts. Tune state with events. Okay. And then here we're going to take parts sub A. Part sub A sub 0. Okay, let's see how that does. Event to parts. Dot make. Okay, let's see if this cancel. Try this again. Oh, something's still not happy. Measure, okay. Yeah, we shouldn't be referencing tune if this works. Okay, time signature we used down there. Let's just inline that. Okay, create the events ABCD, convert that to parts, make sure that the A part gets it in measure 0 is those 4 notes. Okay, that seems good. No measure for non-existent part. Okay, that's... That's really more of a tune question or a parts question. Yeah, I'm okay leaving that back in Tune Builder. That's kind of a higher level question. Tune returns no measure when out of range. Again, I think that's more applicable here. Okay, so this, we want to make sure it does the key signature. So let's let parts equal event to parts. Initial state. What do we call that? Tune state. Let me go look at tune state. I don't know if I can still say key equals. Maybe not. Okay, and then events are this. Parts equals state with events dot make, and we want to look at tune. Well, what do we want? We don't have a tune. Oh. Oh, wait a minute. You have to be able to change it. Wait, it's a var. Oh, I didn't make it a variable. Did I leave off make? No. Event two parts of state and events dot make. Parse. Oh, it is. Okay. Yeah, we're testing a slightly lower level. Okay. All right. I think we can. Let's close the right. Okay, meter time signature. Good. Handle meter in the tune header. All right. So that will be ABC parser. Unit note length in header. Well, that's going to be similar. Borrow that to get us going. Okay, test meter line and tune header. Okay, rhythms. parsetune.nodes.map. I don't think I want that part. Okay. Let's see what parse tune give us. A tune. Tune dot measure 0a. And I think we want to assert that measure dot rhythm should equal rhythm. Let's start easy. Okay, or no, we don't care about that part. Let's do this. Meter 3/4. Should fail. Parser error. Okay, came up 4/4 instead of 3/4. Okay, so it's ignored right now, I guess. Let's see. So it's the parser. Okay, we want to deal with the tune header. Line starts with K, with L, with P. Otherwise, tune header starts. Let's see what that contains. Let's take M out. That makes me think there's something wrong with our tune body ones. But anyway, oh, it doesn't. Never mind. Okay, so tune header. Well, let's just add it in here. Else if line starts with M, then we want to do something. Well, I guess we want to get the meter, and we'll try parse it of. I don't think we have anything that does this, right? We have rhythm, but the rhythm on a note is different. ABC parser. We don't even have a rhythm parser. Okay, so let's see. So I guess we want a meter parser. And line. And then we want to do something. Okay. Well, I don't think we have this yet, right? Okay, not surprising. All right, let's just stop. We'll just print meter. Okay, so our test assumes there's going to be a meter parser, and we'll add that up here. And then down here. All right, and this is the thing that doesn't exist. Let's get that, and we'll make one. And let me get another line, a parser up here. Key parser. Okay, so we need to hold a parser, and well, we need our class, but this is kind of the key piece. Oh, and I just lost it. Okay, in our case, we're cbind. Cbind means character input, and the output is going to be a meter. Okay, and then we need the parser method. Okay, so parser.make. Oh. Okay, that's done deferred here. Okay, we just need the constructor. Yeah, we're going to do this kind of thing too. And I feel like I'm doing something a little funny there, but okay. So the meter parser, I think we have a rhythm somewhere. Maybe not. Okay. Well, let's do the simplest one first. It's 0.9. Well, let's just stop there. Okay. Cannot convert bind character key to bind meter. Oh, meter. Okay. So right now that's not going to work, but we're just trying to get the test failing first. Okay, so this test should still fail. It may print something, but it'll be weird. Cannot convert. Okay, I'm just going to make up an answer, junk answer here. Problem was this thing wanted characters, returns a character, and we need to return, well, we need to return a meter dot standard with that. Okay. Has to be a meter. Only one we have now is standard. We need P combo. All right. I'm just looking for a wrong answer here. I don't need the, still, oh, failing. Okay. I guess ParseTune's got its own problems now. Oops. Well, I messed it up. Okay, let's try again. Okay, so expected a character in 0 to 9, but found meter :3. Well, it was 3:3/4, right? It didn't didn't really like the slash. Okay. That's that one. And then the actual content, we returned 4.4, which is our default now. Okay, we haven't made enough progress till we get to 77/4. So we're, what, meter parser. Okay, so what this really should be is 0 through 9. Keep the one on the left, followed by a slash, and then followed by another digit. Okay. So just from a parsing point of view, it's a digit followed by followed by a slash, but leave out the slash. There's no greater than that says keep the slash. So we're just going to get a digit and a digit, and then this is a pair of digits. Num denom in. Well, that'll be fine for now. Oh, and it's really not one of, is it? Okay, we're going to get to our 77, though. No, not yet. Okay. Parser helper. Vector character in 0 through 9. Oh, we didn't eat the M colon. Okay. I'm not sure how we did that on these others. I guess we need it there too. All right, let's go double check with this unit note length parser, but I think we'll find where word make is. Yeah, it looks for that. Okay. M colon spaces. And then we want to keep, so we're only keeping what's on the right, only keep what's on the right, only keep what's on the right, and then get to the real thing. Okay. Cannot find spaces in scope. Really? You'd think I would have that defined somewhere. Yeah, that really seems like a... Let's pull that up. I want to make that a free function in parser plus helper. Combo extensions. Yeah, I think that's okay here. Field succeeded. Okay. All right, one failure. That's more promising. Hopefully it's 77. No. Okay. Oh, well, no, it wouldn't be, would it? Nobody looks at that. Okay. So let's get that pushed through. Yeah. So if we get back that meter, whatever it is, let's see. Try and get things where I can make use of them. Okay. So what happens is we match the M. It returns us a rhythm or a meter. We don't do anything with it. Do we print it? Let's just run that one test. Yep, there it is. So we are seeing it, but we haven't done anything with it. So I'm driving this from a very outside test that maybe may not be the best way to go. All right, so let's do tunes.set meter of meter. Okay, and this isn't going to exist. So we'll do that. Okay. Meter. All right, and then our tune builder doesn't have this function either. All right, now this thing doesn't have it. Initial state, tune state. I know it doesn't have it because we only created meter this morning. We haven't touched tune state. Okay, var key in. Var meter of meter equals meter. We'll default it this way for now. I don't think we want to live there for long, but we're pushing through. Okay, so now tune state knows meter. All right, tune builder sets it. Okay, and then we need event to part. Oh no, yeah, event to part needs to take it into account. Okay. Okay, so make, well, where do we set? We have the initial state coming in. So I guess Tune Builder is going to be responsible for that. Oh, it is coming in. Okay. Just make metadata. There's initial state coming through. Okay. So event to parts. Where's our measure time signature? Yeah. Where's time signature defined? Okay. I don't think this is right anymore. Okay. I think just like other places, we started going to state for this. So this should really be getting state.meter. Oh, wait, does measure should take, oh, we don't do it yet. Okay, this is good. All right, so now I'm saying we should have a init that takes a meter. And we may have a few places that need to adjust, like tests that might need to adjust. I think in real code, this is the only place we'll see it. Oops. Empty. Okay, everybody caught up? I still think there should be some tests. Yeah, those are all tests. Good. Oops, quantizer. Um, I guess this is measured meter. Okay, I'm going to add that meter. Is that the right name? I don't know. Measure rhythm. I guess this is going to be. Some of these will go away. Okay, I think we're back to running. And I hope we get a 77.4 on the output side. Okay, moment of truth. Yay. All right. I guess we're going back to that same path. So we got ABC parser. Let's see, where's our meter parser? Okay. So this thing, instead of returning that, we know it has a digit. Well, let's make this, well, we'll do this first. Okay. 0 through 9. All right. So we want to take the numerator is a string. Oh, I always forget. Well, okay, sorry. Character. Sorry, I'm just going to change this. Digits. Okay, so now we have digits and digits. All right, it's digit and digit. And I think I can put that on a new line too. Okay, and this is meter standard. Okay, so those are now characters. I'm gonna make them multiple digits, because you certainly can have 12.8 or 3.16 or other things. Okay, but now they're strings. So I forget, is it int, source, clamping? There's a million of these. Text. Yeah. Text is num and int of text of denominator. I don't know if I need a bang on those. Yep. Contextual closure. Expects one argument, but two were used. Okay, so we're not doing catching that. Take this, keep that, keep the left, but throw that away. Keep both and keep that. Okay. Maybe I have to do this. I think maybe I can't peel them apart here. Really? Int text colon. Oh, you don't give it a. text. I still don't know if I have to exclamation point that. Right. Oh, come on. Okay. Feels anticlimactic when we have so many climactic when we have so many pieces we had to do to set it up. All right, but let's drag it through. We got M colon spaces, then digit, match digit, digit. I feel like we should have spaces after that. Let's see what we do for unit. Oh, length unit. Yeah, we really should have spaces here too. Okay. Let's make sure nothing breaks with that. Okay. So we make measure take meter rather than rhythm, and then we parse meter and assign through. Okay, and I guess I want to make well, that's good for now. All right, I do want to check out, make sure these spaces aren't significant to it. I guess I could change my test. I mean, if I had written my test in 3/4 like that, that should still pass. Okay. All right. We've been going a while, so let's go ahead and take a break, 3 or 4 minutes, and we'll come back. And I think we're ready to move this through to the in the middle of the tune version, so we'll tackle that next. Hey, welcome back. All right, so we kind of have two directions we can go. One is that there's more complexity than we allowed for. We had these standard meters, but we also can do common or common cut time. We can have none, or we can have this compound meter. Additive meter, I think is the right word. Compound usually is things like 5/8 that are kind of a 3+2 sort of thing. Okay. I guess we could go fill in all the other meters, or we could manage the meter changes in the middle of a line, well, in a line or within a line. I don't know. I kind of am inclined to capture the rest of this stuff while we're in that parser and just get this piece done. Okay, so um, well, none. Let's address none. No, let's go ahead and do C. C and C bar. Oh, and then we have this one. Maybe this one's easier to do. I'm going to interpret parentheses optional. I'm going to say you can even have unbalanced ones. I don't think we need to be too picky on this one. So let's handle this meter thing. All right, so I think our meter parser, let's move that over. Wow, I keep getting so much stuff open. I want to pull this out. What? Yeah, I think this whole thing is it's only going to get bigger. Okay, so let's make a function. This is a numeric meter, and it's going to return a meter, and it looks like this thing. Num denom is the incoming thing. Num denom is, and here I think we can say, no, string. It was array of character, wasn't it? Okay. And then that. And I think I can pipe that to numeric meter like that. See if everybody's happy. No. Can I find numeric meter in scope? Oh, I got one extra. Okay, that should still be working. Okay, so let's see. The stretch from here to here, let's make a little parser for that. This is the numeric meter parser equals this. Okay, so we just pulled out that piece. It should all still work. Okay, now I'm going to make it a little more let's say this is optional, match left parent, And then we're going to ignore that and allow digits. Match that. Okay. Before the brace, we're going to keep the thing on the left and allow an optional right parend. Okay. Actually, let me drive some tests in for this. Okay. So if I call can I call? Well, I think I can call try it. So let's go ahead and make a test for this. All right, so the meter parser, I think what I want to do is I want to create one of these and then call parse on it. Okay, so let's make a func test. Standard meter. Okay, so let parser equal meter parser. And then is it try parse it? Parse it of parser and line. Let's call this, let's do this as a check. Meter parser, you got to give me the line. String, okay. Convert that to a substring. Is that right? Oh, try, yep. Okay, so we're going to parse this. The result should be our meter, I think. Yes. Okay, so let's say meter equals. This is only for successful ones. All right. And then assert equal meter expected. Let's pass in a meter. Well, this is okay. I think I can call this multiple times and not be too unhappy. It's sort of a ultra cheap parameterized test, I guess you'd say. All right, so let's check meter parser. If we get, well, let's say body, and let's let line equal m colon body. I don't want to repeat that m colon whatever all the time. Check meter parser. Let's look at 3.4. Should be meter dot standard rhythm 3.4. Now let's do 3, 4. All right, and this should fail, right? We don't support it, right? Cancel. First one should pass, 13 should pass, 14 should fail. Oh. Expected 3. Position 3, expected character in... Oh, did I mess up the spaces? Spaces, M colon spaces, numeric meter parser. Position 3, expected character in 0 through 9. Where's that spaces? 0 more spaces. I would expect that to be okay. Let's take the space out here for a moment and just make sure. Oh, I saw something go by weird in there. No. Okay. Position 2, expected character in 0 through 9. Just to make this more, I think, more clear, M colon, position 2, expected character in 0 through 9. But the meter parser definitely looks for an M colon, spaces, and then numeric meter parser. Well, why would that break? Okay, I guess we'll check out what's going on here, I guess, just to make sure. Well, M colon 3/4 looks like the thing. All right, where's our test at the top level? Because I sure think that looked very similar. Oh, maybe I need the new line? I don't see why. Hmm. Wait. Three, 4. Okay. Well, I'm going to put these back like they were. I think they were. Match M, ignore it, keep the right, ignore it, keep the right, ignore it, keep the right, digits, followed by match slash, ignore it, digits, keep it, spaces, ignore it. Okay. This parser is not easy to trace through, so I'm not going to try. But let's make sure body is what we expect. Line is what we expect. And expect it. Okay. Go. Position 2, expected character in 0 through 9. It's almost like I have a weird... Okay, I totally don't get how M:34 is apparently fine. I don't think new lines come into it. Position 5. 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, 5. Position 2. Oh, wait. This one passed, that one failed. It should fail. Ugh, okay. Ugh. Make sure this one passes. Yeah, okay. We're failing on the second one with the parentheses because we don't support them yet. All right, some days. Okay. So that was digits through digits was numeric meter parser. That should pass, mostly pass except for the one that should fail like it did. Okay. Second one failed. Good. All right, now allow this match. And let's keep on the right. And this match, keep on the left. Okay, so match upper end if it's there, ignore it. And match the digits. Ignore right parens, match the slashes, and the digits. All right, I think this should pass. Okay, meter parser test. Sometimes I like to throw in a what. What is a string, and we just put it on the assert equal. Okay, so this is Okay, these should pass just as well. Okay, so let's commit that. Allow parentheses. Yeah, thank you. In meter. Okay, now let's do this additive meter. The text is, well, let's just go for what they gave us. 2 plus 3 plus 2, 8. Should be meter dot additive 2, 3, 2, 8. Okay, additive doesn't exist yet, and what we're doing is additive meter. All right, and I'm going to change this to just check. Okay. All right, so we need meter class to accept additive. And it takes an array of int and an int. Okay. And we should get complaints. Okay, let's do this one first. Case dot additive. This is numerators, denominator. Okay. Let's return brackets. Well, I'm going to let numerator equals numerators dot I don't want lazy. I want oh. Let's turn them into strings. Join them with a separator. Okay, so we got 2 plus 3 plus 2. And then we'll just put that in here. So that's numerator slash denominator. Okay, and then return, I'm just going to return common. All right, so I'm not meter and tune header. I think we can be more specific. Well, we had handle standard meter. And let's take this for now. 22-35. This is November 22nd. Today we're doing time signatures. Take this here. Okay, so we did the tune header. Any meter in the tune header. Standard meter, we did that. Let's do additive. That's what we're working on now. All right. Oops. In our test, well, sorry, what I came here for was we need to make sure we handle additive meters rhythm. Okay. So meter parser tests, right? That should be meter.additive. Okay, this test should fail, but it's well defined. Oh. Four, whatever. It's not right. Wow. That's not where I'd expect any trouble to be. Bad access. Deep Swift unmutable pointer array. Ugh. Oh, tune. What's going on here? Okay, well, he's got an empty measure. That's certainly not good. But key changes should have nothing to do with bad access. No values. That should be the case. I mean, it shouldn't be the case, but apparently is. Okay, this is really weird to me. Some stuff's working. Key changes in body does not. I'm going to clear the clean test results. I can't do. That's just really may have to be stopped. Okay, let's try them all again. Okay, what is going on? I just added a meter to allow additive. I returned 4.4, but nobody should be calling additive, so I don't see the issue there or here. Like, what changes do I have going? Meter changed. Well, let's just return that. I'm going to diff this. Meter additive returns something. Returns something. And then this. Could I have stepped on something with the name check? I don't see why. Wow. Um, okay. This is puzzling. Let me go back. Let's just. Oh, I don't want to mess with that. Can I div? I don't understand where this thing is dying. Let's stop here and take a look. That is a little weird. Oh, that looks okay now. Yeah, fine. Something in assert equal is not happy. All right, let's do this. Now this time it's an unsafe mutable pointer. The last time it was completely valid. If I say map each one to itself, it's an F and an F. F in the key of G, followed by F in the key of C. That's what we'd expect. And is this an array? array of symbol. And that's an array of symbol. Yeah, I don't know. Okay, let's see this one. Well, our additive thing is completely not right. We never call additive. Okay, I'm going to run it again. Okay, I don't know what was going on there. Maybe the clean build helped. Okay. Well, what's going on here? We don't have anything that returns meter.additive. So let's go look at not meter, but meter parser tests. Meter parser. Okay. So here we don't accept plus signs. All right. But we have an operator for that, and it is it's something with a star. Well, separated by, what is it? Oh yeah, 2 ampersands. Okay. Yeah, this is kind of the equivalent of exponentiation. So we say you should be able to match plus signs. All right, and here we're saying we only want to keep the digits of that. So this becomes an array of these, which is arrays of characters. Okay. And then the denominator. Right, that's array of characters. This becomes array of characters. Let's see if it's complaining. Yeah. Can't convert character to expected type, aka array of character. Okay, so up here, this is array of arrays now because we're allowing multiple occurrences of digit. Okay, and here num is an array, so let's just take num sub 0. This should get us back to where we were. Build field. Array of character. Oh. Okay, something's funny. I think what's going on is if it sees an array of things and a thing, it makes an array out of them. So this should be well, this part goes away. And we don't need parens. Don't need the left paren. Okay, array of character. Now, num denom, we don't need that. Well, we can say let numerator I'm just trying to get the old tests, make sure they still work. Okay, and this is num and denom. Okay. Oh, I saw question marks in there somewhere. All right, let's see what we got. 2/3 is not equal to that. Right. I really should take last. That had kind of crossed my mind. Why the spacing keeps messing on that. Okay. It should be complaining about 2/8, not 2/3. Okay, one failure. 2/8 is not equal to additive meter. Okay. Yeah, so we got the first one and the last one, but we didn't get these. All right. So now we'll deal with this. Okay, so if num denom dot count is 2, then we want to do that. Else we want to return meter dot additive, and we want this to be num denom dot last, and this to be num denom dot end. Not that one. It's like take, keep. Drop last. One. Okay. Right. We're gonna have to map all those. Okay. All right. So let's do the mapping first. Okay. Let numbers equal num denom dot map, and we'll take int of string of $0. Okay, so we're going to map everybody to the corresponding integer, and we can look at numbers dot count because that doesn't change by the map. Okay, and in this case, I think we can say first okay, and then well, this is numbers. Now we've already mapped them with int of string. Okay, and that seems okay. And I think even this, we can just inline these. All right. So we'll take these lists of characters, array of characters. walk through the arrays one array at a time, convert each array to a string and then to an int. And then if it has two things in the array, then it was 3/4 or something like that. And we'll take the first and last number as the values. If it was an additive, then we want all the numbers except the last one. All right. And let's run this test again. Okay, so all these should work. Period. I do want to pause here. This question mark thing, that's not good. Let's fix that first. We'll just say true or. Okay. We want that last one to keep failing even though we kind of have a solution. I want to see the failure message because I think I don't like it. 2/8 is not equal to question marks. Additive meter. Okay, so let's go to meter. Oh, okay. Now I can kind of justify this. Even though it's a debug description, I kind of let it drive that, but I want a better message. I can get it here. Yeah. 2/8 is not equal to 2 plus 3 plus 2 over 8. Okay. So I like that message better. All right. And now this should pass. Okay, now the thing that's not working is meter. We said, what's your rhythm? And we don't really answer the question here. Okay, so I think it's time for some meter tests. All right, let's sort this again. I thought I could default it to that, but apparently. Okay, so the deal is this one's pretty obviously, it has a rhythm. It should just return the rhythm. This one also moderately obviously, 4/4 is not the answer. You know, it should be looking at the values it stored. Okay, I'll just make a little test for that. Okay, so if we say, oops, let's make this function test. Standard meter knows its rhythm. I think that's okay. All right, so if we say let actual equal meter standard four. Was it int or rhythm? You know, we might be better off with just keeping those ints. I don't know. This feels inconsistent, doesn't it? Okay. Well, let's test what we got. Rhythm 4 dot rhythm. Okay. Actual should be rhythm 4. Okay, so standard meter knows this. Cancel, fix this. That test should pass. Let's make this 16 just so it shows up different. 8/16. Okay. This one I expect to fail with 4/4 because we defaulted to that. Okay, 4/4 is not equal to 8/16. That is true. Okay, so what we want to do is return. Well, this is let numerators, let denominator. And we're going to return rhythm. We're going to take numerators dot sum, I hope. Oh, what is it? Numerators dot. I thought they had a sum. Oh, come on. Swift sum array event. Well, yeah, we can do multiple. We can do a reduce. Is that really what we have to do? Yes, I guess. Okay. Initial value and the combining operator and the denominator. Okay. Should pass. Oh. Oh, some people can't add. Okay. That should pass. Maybe it was a better test with a 7, actually. 2 plus 3 plus 2 is 7. Okay. That should pass. Okay, let's see, meter. Well, we've done the additive one. We've not done common, cut, or none, or free meter. Okay, so let's get our common. I guess parser test is where this goes. And I think that's okay like this. All right. This, we've used that word already, so that's a little bit funny. All right, let's see meter. Okay, this should fail. Fail to parse. Okay, position 2, that's the C, I guess 0, 1, 2. Expected character in 0 through 9. All right, so meter, we don't have a, well, we need common time down here. Case common. Oh, sorry. This should have case common. This probably should go away. Case common, and then we need to add it here. Okay, I'm just returning a consciously wrong answer. Case common. Let's just return common 4, 4. Okay. Now somebody may go a little crazy, or somebody else may fail. Yeah. Okay. Let's see who's failing for here. This failure is still parse failure. Okay. Yeah, we haven't dealt with the parser, but the people who kind of used default before aren't happy. Meter common. Okay. So let's go back to meter tests and make sure common meter knows its rhythm. Now, okay, well, we'll do this cleanup later. Common.rhythm should be 4, 4. Okay, and we hard coded it to 1/16, but it really should be 4, 4. That's not it. Make sure this one's working first. Okay. Tune knows its measures. Okay, now let's check the rest. Okay, whoever defaults that 4, 4, I think they should be defaulting common. So that's in the event to parser. Yep, there it is. Default meter. This isn't even right. You don't let me do that. Only a little. Tune knows its measures. Well, right. Now maybe this is a question of meter matching. You know, I think it might be that we want to say this should really be the equivalent of 4/4. Now, this is doing event to parts. Yeah, I think it's taking the rhythm. Maybe it's doing a math on the rhythm and it just shouldn't be. Our default meter is not a meter. That's suspicious right there. Well, okay. Yeah, so suspicious because nobody's even using it. All right. Initial state. State.meter. Okay, let's find initial state. State meter dot. I think this should be common. For now, it's wrong, but I think to be consistent with what we've been doing, it should be common. We haven't got around to free meter yet, and that's what it really should be. Okay. Now, where are we? Okay, our parser does not handle it. All right, that's where we want to be. Let's take this back out, and we'll just say we added meter.common. I don't know, am I wimping out there? Okay, and then this now fails. Let's go find our parser. Good. Okay, so here we got numeric meter parser. We should also have a C parser. And to get there, you're going to match common. Okay. And if you do, you're going to return meter.common. Okay, pretty easy. And then here, this is either, well, this becomes numeric parser or C parser. And then we can also use this default thing. It's not question, it's oh, golly. It's part of the optional stuff. No, it's part of the or else. Name. Percent, that's right. Meter parser. When we put ors, we usually put this. It expected meter. Well, I don't think we need to do that here. We're not through everything. Okay, so the key thing is the two possible paths. Here's numeric meter parser, and let's take that going here. Okay, so if you parse it with numeric meter, we call numeric meter the function, and return a meter in either case. And if you match a C, we return meter.common. And so either one of these two will apply and return a meter. This ignores the rest, so that result is good. Okay, and I think that should make our test pass. Good. All right, support common meter. Now, if I have a measure in common meter and I have a measure in 4/4, I sure think that ought to be compatible. So I'm questioning our implementation of equatable. It doesn't necessarily stop us for now, but I think we will want to do something about that. So let me add that to the to-do just as a questionable one. Well, handle additive meter and the rhythm, we've done that. We've also done handle common meter. And we've left ourselves with a question mark. Should meter equality work across its cases? I kind of think the answer is yes, but all right, let's handle cut time. Okay, so meter parser test. If you do C bar, it's meter dot cut time. Somebody should be unhappy about that. Yeah. Okay, so meter, we will add it doesn't need any information. (1/16). All right. C bar equals 2, 2. I don't know, maybe I want to say cut and common. All right. There you go. Okay. Up here, we get a parse complaint. Unexpected character. Okay. Meter parser. Well, you know what? I'm gonna back that test out for a moment. Okay, and our parser, we do the C match. Well, it can be followed by an optional bar. Okay. Cannot convert value of meter to closure return type. sorry, this should be followed by, not or. I think I can do it this way then. Okay, now our failure should be that we don't have the right type. We're getting common back instead of cut. Okay. And I think that's enough to make us make a little helper function here. C meter, and what it gets is well, it gets, I'll just say common bar of pair, and the first one is a character. Oh wait, we don't need to know that. If we match the C, we don't care what it is. So this one is just character optional. All right, so I'm shortcutting this again. All right, so we get a value in, and we're going to go to C meter. And that's basically the same. Okay, so right now we get an optional character. We're not even doing anything with it. We just return common. Okay, that should take us where we are. Parser test. Comma is not equal to cut time. Okay, right. So the real answer is, I would call this maybe the cut bar is a character. So if cut bar is nil, I guess it's return. If it's nil, return common, otherwise return cut. Good. I think that should do it. Right. Okay. Meter parser tests. Yep. Okay, now let's look at meter. We didn't really address this one. Okay, so cut time, I think we said it should be 2-2, right? So, yep. Okay, so let's find our tests. Let's say totals its rhythm. Common meter is 4-4. All right, this should fail. That should pass. Okay, meter knows rhythm for cut time. Okay. I have some question in my mind about this equality thing. Let's clean up this test a little bit first. This is check meter rhythm. It takes a meter and expected of rhythm, and let's do a what of string. Okay, so this is meter dot rhythm. This is expected and what. All right, so test meters know their rhythm. Okay, and this one is check meter rhythm. Dot standard 4/4. Expected is rhythm 4/4. And what is standard meter? And just to make it vary up these values a little, do that. Really? Are you complaining you don't know meter? Print. Okay. Check meter rhythm. Additive. Okay. Okay. There's to do, handle cut time. The question is comparing rhythm, I think. I feel like the answer is probably supposed to be right. To be yes, it should allow them to be equivalent. Let's see, what else do we have? Okay, we got standard meters, common, cut. We don't have none. Well, let's handle free meter. None. Okay. I think we'll leave off there. It's pretty straightforward what to do. We'll have to add a none meter, and we will we'll add the meter. We'll make our parser recognize it, and then we'll address this equality. And I think that will cover us. We've done all the meter stuff, and we'll go handle that in the tune body, which requires a new kind of event. We'll add that and go forward. But I'm pretty sure we're on track. We'll finish that tomorrow sometime. All right, so our next session is tomorrow, Wednesday, and it's 1 to 3:30 p.m. Eastern Standard Time, or 6 to 8:30 p.m. UTC. So thanks for joining today. Hope you had a good time. Hope I see you again. Take care. Bye-bye.